working with today is just working off of deciding whether or not some copies of figures would be considered proportional or not. So in a computer art program, when you click and drag on the side of a photograph, you distort it. So what they're referring to is if I were to click and drag on this little arrow, it distorts the figure of the original. So if this is our original figure, notice how the face became bigger. Okay, it became wider. It distorted it or it changed it. If you click on the top or the bottom of a picture and you modify it by making it longer, notice how once again the face became much longer than it would have before. Okay. In order for us in a computer program to create something that is proportional, we click and drag on the corner, and therefore it will pull it in both directions, both of these directions in the same situation. So that would create a proportional shape or figure. In other words, everything remains the same other than the fact that it just becomes larger. Okay, we end up with the same shape of the face. It didn't become wider or narrower. It just became larger in size, but so did everything else. Okay, today what we're going to be doing is we're going to be working with some reducing of photographs. So we have these 3 photographs here, and it says you're trying to reduce the photograph to the indicated size for a nature magazine. Can you reduce the photograph to the indicated size without distorting or cropping? Explain your reasoning. So what cropping means is cutting it down or cutting pieces off of that picture. So when we go through to check this, remember way back when, we used to work with proportions. This was probably back in chapter 3, where we would check proportions and see if they were equivalent to each other. So for example, we might have worked with 7/8 and 15/16. And we would go through and we would check to see if those were proportional. So there were 3 different things that we did. We either chose to go through and change these to decimals and do 7 divided by 8, and then 15 divided by 16, and we would compare the decimal forms. We could also go through and change these to be equivalent fractions. So we could take this times 2, because that would give us 16, and take 7 also times 2, which would only give us 14. So there I would say that it was 14/16. Those are not equal, so therefore they wouldn't be proportional. The other method that we got used to using that works 100% of the time, not that the other ones don't, but sometimes those other ones are hard to see, is we would go through and do cross products. So we would multiply each of these and see if our answers were the same. So 8 times 15 would give us 120. In order for them to be proportional, we would have to get the same answer. So then 7 times 16 gave us 112, which we could see earlier they were not proportional or they were not equal to each other. So in this situation, this would be a no, they are not proportional. So this is the concept that we're actually going to be using today. We're going to take the numbers that are given and we're going to go ahead and set them up and then check the proportions. The key thing is to make sure that common sides are on the same level. So if I write this one out as 5/6, then I need to make sure that my side that was the same as the 5 is in the same position. So my 4 needs to also be on the top. So 4/5. Now we can go through and either check decimals, check cross products, check equivalent fractions. I like cross products myself. 25 and 24. Are those equal to each other? No, they're not. So these would be considered, no, they are not proportional. Okay, so we could not size it down a 5/6 inch photo to a 4/5 inch picture box and not have to cut any of it off. Okay, so let's go ahead and try the next one. So we have 5/5 and 4/4. Check cross products. There's 20. Oops, and 20. There we got them the same, so this would be a yes. Okay, so why don't you go ahead and finish out letter C and check to see if those are proportional or not. If you could size that 6/8 down to that 3/4 without having to cut anything off. So in other words, are they proportional to each other? So go ahead and do that one. This would also be a yes, they were proportional. And some of you might have noticed right away, well, 6 divided by 2 is 3 and 8 divided by 2 is 4. Or you can always check your cross products, okay? So that's working with reducing a photo. In other words, when we do this and we don't want to change the photo in any manner, we have to have proportional sizes. Okay, so we're going to go ahead and do another activity. It says, tell whether the new designs are proportional to the original designs. So once again, in order for them to be proportional, if we set them up as ratios, they have to have the same cross product, okay? Or they have to have the same decimal if we want to reduce them down. Okay, so if we go through, this is going to be our original. So we're always going to use this one. Okay, and then we're going to do design 2 together, and you'll do design 1 on your own. Design 2 is a little more complex because of the fractions that are in there. So we'll do design 2 together. You will do design 1 on your own. So if we want to check, once again, we're going to use the same concept that we did before. We're going to go through and set this up as proportions. So I need to use 2 sides that are different here. I can't use 8 and 8 and 6 and 6 sevenths and 6 and 6 sevenths because we won't see if they are proportional or not from that. So we need to use 2 sides that are different in lengths. So we're going to use 8 and 7. And then we will use 6 and 6 sevenths over 6. So 6 and 6 sevenths over 6. So this one's a little bit harder to kind of go through and check. But we'll go ahead and check our cross products. So if I go through, I'll do the one that's easy first. 6 times 8 is 48. And now if I check this one, 7 times 6 and 6 sevenths, well, we're going to have to change that into an improper fraction. So 7 times 6 is 42 plus 6 gives me 48. So I'm going to do my work for this. I want to do 7 over 1 times 48 over 7, right? So now if I check, cross cancel, 7s cancel each other out. I end up with 48 over 1 or 48. Are those equal to each other? Yes, we got 48 for each of them. So this would be a yes. This one is proportional because we ended up with the same numbers when we checked cross products or the same decimals. Okay, so what I want you to do is I want you to go through and do the same concept, only this time you are comparing to design number 1. So go ahead and do your process with design number 1 and then check back on your answer. So you should have gotten no for design 1 because you do not get equivalent or proportional ratios. We ended up with 48 versus 49 if you check cross products. Okay, so now we're going to go ahead and move on to letter B. Same concept, only this time they're asking us to actually draw the figure. Okay, so I'm going to slide this up. It says draw 2 designs that are proportional to the given design. Make one bigger and one smaller. Label the sides of the designs with their length. So what they're telling us is we are creating similar figures and we're going to go ahead and actually draw these out. Now we're going to go ahead and just draw them. One's bigger, one's smaller. We're not going to actually take a ruler out and measure it, but we'll go ahead and actually draw these out. So my first thing is I'm going to do one that's bigger. So to do one that's bigger, I'm going to take each of these numbers times 2. Okay, so we'll do our bigger one first. So I have a bigger rectangle. Remember, once again, we're not actually going to draw them to actual scale, but we're going to go ahead and do this. So I'll now use my dimensions to show my scale. So 5 times 2 would give me 10 for the height, and then 4 times 2 is going to give me 8 for my distance across there. So that's my bigger rectangle. So now I'm going to go ahead and do one that's smaller. So let's go ahead and maybe divide these by 2 this time. So we'll divide each of these by 2. So I'll do a smaller rectangle. And then I'm going to use my dimensions. So 5 divided by 2 would give me 2.5 for the height. And 4 divided by 2 would give me 2 for the width. Okay, so there's my similar rectangles. The dimensions, if I wanted to go through and check them to make sure they are similar, which they should be because I already said they were going to be, I could check. So I could use 5 over 4 and then check 10 over 8. I should get the same answers, 40 and 40? I do. I can also check on the smaller one. Because when I'm multiplying or dividing that rectangle measurements by the same number, I'm creating proportionals, but I'm just proving this to you. So then 2.5 over 2. So here I would get 20, and then 4, oh, that I meant to write 2. Here I would get 10, and here I would get 10. Those are proportional. And you don't have to do that second part. I'm just proving to you what they are. Okay, so on these next two, I want you to go ahead and do the exact same concept. For one of them, you're going to multiply by 2. And for the second set of that, you're going to divide by 2 on each of these. So you're going to create 2 triangles and 2 parallelograms. So go ahead and do that one. Finish that out. And then when you're finished, you can come get my answer key and check off to make sure that it's correct. So that's basically it for this activity. This activity is working with proportions and whether or not we are creating proportional relationships, or in this case, proportional figures. In order for them to be proportional or similar, they have to have equivalent ratios.